this unit is all about solving systems of equations. And today we're going to look at the graphical method for doing that, how to solve a system of equations by graphing. But we're going to have three methods for solving. One of them is graphing, and the other two are algebraic methods for solving. And there are advantages and disadvantages to both algebraically and graphically solving, but which is why we need to learn multiple methods, because sometimes graphing is the appropriate way to do it, sometimes algebra is. So we'll learn all of those methods. And this is something that in Math 20-1 and -2 you're going to use. In Math 30 you're going to use. If you take calculus at some point, you're going to use this. This is going to keep coming up over and over again. When you're asked to solve a system of equations, you're given two equations. Well, usually two. It could be more, and eventually it'll be more, but two equations with two variables. Because usually when you're asked to solve something, you have one equation and just one variable, like they're all x's or all y's or whatever, but these equations have both x's and y's in them. If you want to solve for two variables, x and y, then you need two equations. If you wanted to solve for three variables, you would need three equations. However many variables you're solving for, that's the number of equations that you need. So up till this point, all of your solving has been one variable, one equation. But now we're going to be looking at two variables and two equations. So basically, this question, when it says solve, and it gives you a system of equations, which just means two or more equations that you're considering at the same time, it's asking us to find an x and y value that satisfies both of these equations. Not just one equation, but both of them. So the way we're going to do it here is by graphing y equals 2x plus 1. And you should already know how to graph that. So this is from 2 units ago. We're going to start with the y-intercept of 1. We'll put a dot there. Right? Y equals mx plus b, so y equals 2x plus 1. Start at the y-intercept of 1. The slope is 2, so that means from there you go up to and over 1. So there, up to over 1. And then do that again, up to over 1. You could do it as many times as you wanted, but that gives you the line. So I'll draw that in. It's kind of squiggly when I draw it on here, but that's what that line y equals 2x plus 1 looks like. And then we're going to do the same thing with the other line, the y equals negative x plus 4. So for this one, start at 4, and the slope is negative 1, so we'll go down 1 and to the right 1. And we do that a bunch of times, and we end up with this line. That's y equals negative x plus 4. When you're looking for the solution to the system, it's where the two lines intersect. And they intersect at the point 1, 3. That's the answer. Or you could say it as x equals 1, y equals 3. If you fill 1 and 3 into either of those equations, it comes out to a true statement. Y equals 2x plus 1. Well, 2 times 1 is 2 plus 1 is 3. So that works. If you do it with the second one, negative 1 plus 4 is 3. So it works for both of them. Here's another similar question. But what's the difference with this one?
That one has an answer.
You have to put it in the right form first to be able to graph it, right? So it's not in slope-intercept form. We want to put it in slope-intercept form. The first one, we can just subtract x from both sides. And we get y equals negative x plus 8. And so when I go to graph that, start at 8. It's kind of off my grid. The slope is -1, so go down 1 and to the right 1. And all those points are points on the graph. There's the first one. Whoops, more or less. You can do a better job on paper than I can here on this. My line's a little off, but the points are in the right spots. For the second one, I can subtract 3x from both sides, and I'll get -2y equals -3x plus 14. And then I need to, divide by -2 on all of them, right? So then I end up with y equals 3 over 2x. Those two negatives cancel each other out. So it's just 3 over 2, x minus 7. So go to -7. Then the slope is 3 over 2, which means go up 3 over 2. They met up at a point there.
6.
This is the line. What is that point?
6.
6, 2.
X.
So you can write it as an ordered pair, 6, 2, or you can write it as x equals 6 and y equals 2. Those are the values of x and y that satisfy both of those equations. X plus y equals 8. 6 plus 2, yes, that's 8, that works. 3x minus 2y equals 14. So 3 6s are 18 minus 4, that equals 14. We can just quickly check by filling them back into the equations.